We are going to start now. Hello, everyone, and welcome to session. We are going to be talking about extending System Center monitoring to third-party database engines. My name is Oleg Noskov, and I'm the software architect with the company called Bridgeways Software. Bridgeways is a US company based in New York City, and I work in R&D office in Ottawa, Ontario. Bridgeways has been a Microsoft partner since 2007 and is offering a variety of operations manager management packs for monitoring databases, application servers, virtualization environments, and other cluster computing environments. So looking at our agenda today, of course, we know that System Center can monitor SQL Server really well. Today, we will cover a number of topics related to common tasks enterprises are facing when extending System Center to monitor beyond SQL Server to some popular databases, such as Oracle database, DB2, Informix, and MySQL. I'll be talking about how to approach building database management packs, discuss typical database metrics that are essential to successful monitoring of database performance. Monitoring of Oracle real application clusters will also be covered as an example of clustered database environments with its own specific metrics. Later, I'll hand over to my colleague Randy here to talk about management pack lifecycle and best practices. So when you have all these database management packs and some other management packs, this is supposed to make your IT job really, really easy. In the end, we will move to explore some of the possibilities on how you can use data found in So sorry about that. In the end, we will explore some of the possibilities you can have when exploring data contained in System Center's own databases. There is a wealth of information in the collected metrics that you may be surprised of what is there, and you don't know until you look at this. And we will have a pretty long session with presentation and video and demos. So leave your questions towards the end so we can cover the content. All right? So looking about how to get metrics from database servers, let's look at how we can collect these metrics and make them available to System Center components. Typically, all major databases offer a client SDK, such as a set of native libraries that can be used to connect to running instances of database servers and retrieve runtime health metrics, monitoring data, and event log items, such as critical errors, and warnings. This makes an agent-based solution the most attractive and viable, though not the only one possible. You can potentially have an agentless model implemented as well. But with an agent, you have the advantage of running secure tasks, whether it has to do with remediation of real-time diagnostics, or like restarting your server, or looking at the log files. And these are simple tasks that can be accomplished from System Center itself. It's not something you can achieve with the approach if you have no agent. So Operations Manager provides a way to monitor Unix and Linux environments with the help of providers. So providers are pluggable components into the Operations Manager agent. In Windows, there are providers which are based on WMI, and in Unix, Linux environments, they are shared libraries. Invoked by Microsoft SCX framework, which is the Open Pegasus-based solution. So these providers can only be written in C, C++, and as shown on the left side of this diagram, and client libraries or client SDKs that are typically available from the major databases, they are all platform dependent and come in a variety of packages built for different architectures in 32 and 64-bit. For example, in Oracle, the client SDK is called Instant Client Library. In case of DB2, it's called CLI, or Call Level Interface. And the provider needs to link with these libraries in order to be able to talk to the database servers. They're all unfortunately different. So if you're building a management pack for a particular database, you need to learn a lot of stuff programmatically in order to be able to talk to this database server and retrieve all the metrics. Using the System Center agent model allows management packs to add extra functionality on top of read-only metrics. So, such as remediation of common problems. Through proper impersonation, agent can assume identity of the instance owner and be able to start, stop, restart database instance and make limited changes to the configuration. So basically, you have the option of building your own, or you can purchase something available from vendors. So Bridgeways produces management packs for monitoring of DB2, Oracle database, Informix, and MySQL. And potentially, there are other possible solutions as well. So the agent has a little bit of impact on the server, obviously, because it has to use resources on that server to collect metrics. Our research shows that it's no more than 1 to 3% of CPU usage that is incremental. But this can be mitigated through proper selection and tuning of System Center monitors, because you don't want to monitor things that you don't care about. So looking at the management pack structure and what it consists of, it has various objects, such as rules, monitors, tasks, views, reports, and knowledge base articles. Rules and monitors rely on metrics that are being retrieved from the database server and through the operations manager infrastructure. An agent is just one component in the whole picture of what you need to get operations manager to be able to monitor any third-party databases. You have to build your own management pack and define all the relationships and decide how you want to model the database servers and all the components inside it. That's assuming you want to do it yourself. So let's start from the left side of this diagram. If you were to build a management pack for your particular database server, you basically need to have a very specialized knowledge on how the database server works and its inner workings and how to manage it effectively. As the figure shows, you need to define rules to tell the agent or provider to collect performance and discover data, send events and alerts. You will need to define views that so you can have customized views on each of the database components you want to manage. Of course, you have to have monitors defined as well to track the states, healthy, warning, or critical, of any managed component. Tasks allow you to define activities that can be executed by the agent remotely through Operations Manager console. Most people don't realize this, but you really do need to have a good knowledge base as well there. So textual advices provided within this knowledge base allow the operator to better diagnose and fix the problems. Because the person who develops the management pack is not necessarily the same person who uses it later. Of course, management would like to get from the IT nice summary reports to know how healthy their environment is operating. So reports are essential part of the management package as well. So moving to the center of diagram now, you will need something called run as accounts that are so your servers, so your agent properly impersonates right accounts, right users on the database side. If your database happens to be on non-Microsoft infrastructure, because in Microsoft case, you can use domain authentication, and all the permissions can be retrieved from the Active Directory. And then you need to create pluggable components, providers for in C++ or C for each database server you want to manage. If the database server is a non-Windows platform, then your only choice of programming, unfortunately, is C++, to be able to integrate that run on different flavors of Unix, Linux, Solaris, AIX, or HPUX. At database run as accounts, to be able to successfully perform its activities, operations manager agents need to impersonate local users on the monitored system in both privileged and non-privileged mode. There are situations when agent needs to act on behalf of either database instance owner or DBA. In this case, run as action account is used. On Unix Linux platforms, OS level system administrator account, run as privileged account, is required to be able to remotely deploy the monitoring provider and execute privileged tasks. Typically, for your run as account, action account, to do the actual performance and data collection, you need to assign it a set of rights. You really only want to grant exact privileges needed. Nothing more and nothing less from a best practice standpoint. So it can't do more or collect other sensitive data from unrelated databases or tables. Here we show an example of what one may need in case of Oracle database. In most cases, all you need to grant is read privilege. The actual list of privileges is about 3 times longer, so you really need to have a comprehensive view of your Oracle environment with all these metrics. You have to look. You have to know where to look exactly to get the metrics on performance data and how to apply them. So it means that you need some specialized knowledge in every database environment. So building management packs involves testing them across all platforms and application versions. Typically, we know from a lot of our customers that they have multiple versions of database servers running in production on various platforms and for different purposes, and they also use the different versions of them, including on platforms including Windows Server, Linux, Solaris, AIX, and HPUX. So you have to make sure whatever management pack you build will cover all the database server versioning differences and all of the platform-specific differences. Developing management packs which are more generic and cover a number of platforms and architectures is a challenge of its own. This slide shows how quickly these varieties of providers multiply, even for a single database server, based on how many OS and hardware platforms you need to support. Given the fact that System Center 2007 and Operations Manager 2012 are different and require different versions of management packs, 32-bit platforms and 64-bit platforms are binary incompatible, and database servers themselves have different versions with different versions of client SDKs, you can easily reach an overwhelming number of varieties of management packs to support, even if you're trying to support just a single database product. Unless you have a lot of spare time, and you really need to question multiple times whether you want to build management pack yourself or you want to look at the solutions available on the market that are offered by various vendors. So I'm going to move to show you a short video that shows you how to deploy a provider once you managed to get one built and how run as accounts are tied together. This is the only video you will see, I promise. And I just couldn't do all these steps in this environment and live. So hence the video. So.
Run as accounts and provider deployment on Unix Linux database hosts. This video demonstration will show the setup of run as accounts and configuration of the database provider. We'll show a deployment to an Oracle database running on Red Hat 6 Enterprise Linux server. The deployment involves 4 steps: creation and profile association of a Unix Linux privileged run as account, installing the database provider from Operations Manager console to the host Unix Linux database server, creation and profile association of the Unix Linux Action Run As account, configuring the database provider. Run As accounts and profiles purposes. There are 2 types of Run As accounts required and 2 associated profiles that define what those accounts may do. Deployment. Step 1, creation and profile association of a Unix Linux privileged Run As account. The Unix Linux privileged Run As account is used to provide the access to the monitored Oracle database for root level tasks, such as the tasks used to install and configure the provider for Oracle database on the Oracle database hosts. All Run As accounts that you add to the Unix Linux privileged Run As account, Run As profile, must provide root access to the monitored Oracle database hosts. Before beginning, make sure to record the credentials for each Oracle database host you will be monitoring. Each server requires 2 sets of credentials, one for the Unix Action account and one for the Unix Privileged account. From an Operations Manager console, click on Administration. Right-click in the Administration pane and select Create a Run As account. The Create a Run As account wizard is launched. From the Introduction page, if present, on your system, click Next to bring up the General Properties page. We'll configure the General Properties page as follows for the Oracle Database Management Pack's requirements. For Run As account type, select Basic Authentication. For display name, enter a string that uniquely identifies the Run As account, for example, root or Oracle Database Privileged. In description, enter a string that further describes the Run As account if desired. Click Next to display the Credentials dialog. Configure the Credentials dialog as follows. In Account Name, enter the user ID for the account that will be used to access the Oracle database host, for example, root. Under Password and Confirm Password, enter the password used by the user ID to access the database host. Click Next to display the Distribution Security page. Select the Distribution Security option. Click Create. You have now created a Run As account. Now we must associate that account with a Run As profile. Remember, it's the profile that defines what action the Run As account can do. In the Operations Manager console, click Administration. In Administration pane, click on Profiles to display a list of currently configured Run As profiles. Double-click on the Unix Linux Privileged account to launch the Run As Profile Wizard. Click Next on the Introduction page to display the General Properties page. Click Next on the General Properties page to display the Run As Accounts page. Click Add on the Run As Accounts page to display the Run As Account dialog. Select the Run As account you just created previously from the Run As Account drop-down list. In the Run As account will be used to manage the following objects area. Select a selected class, group, or object. Click on the Select button and choose Object to display the Object Search dialog. Select Unix Computer from the Look For drop-down list. Enter a string in the Filter By field to filter the results desired. Click the Search button. All the matching Unix Linux computers are listed in the Available Items ring. Select the Oracle database host to which you want to distribute the Run As account from the Available Items list, and click OK. Click OK in the Add a Run As Account dialog. Click Save on the Run As Accounts page of the Run As Profile Wizard to create the Run As profile. Click Close on the Completion page to exit the wizard. Installing the database provider from the Operations Manager console to the host Unix Linux database server. After you have configured the Run As privileged account and profile, you can install the provider. When designing a management pack, the best practice to implement this process is to use a task. Manually installing providers on many database hosts can be time-consuming and lead to errors. A task will automate the installation with fewer problems. It should be noted that Operations Manager personnel may not be familiar with Unix Linux installation practices. Therefore, using a task will prevent potential problems. Let's move on to the installation. You can now use the Install Provider Oracle Database task in the Operations Manager console to install the provider software on the Unix Linux Oracle Database servers you want to manage. From an Operations Manager console, click Monitoring. Select Unix Linux servers or Unix Linux computers in the monitoring pane. Click on Install Provider Oracle Database in the Unix Computer Task area of the Action Tasks pane. The Run Task Install Provider Oracle Database dialog is displayed. In the dialog under Run this task on these targets section, click the checkbox beside each host you want to deploy the provider to. For task credentials, select Use the predefined Run As account to use the Run As privileged account created for the selected host. Click on the Run button to execute the task. The task status dialog is displayed that shows the status of any output generated. If the task is successful, click the Close button to close the task. Creation and profile association of a Unix Linux Action Run As account. The creation of a Run As Action account is identical to the creation of a Run As privilege account. Remember, when you first create a Run As account, there is nothing that defines that it is an action or a privileged account. Only later, when you associate the account with either an action or a privilege profile, does it assume its type. The labels that you enter during the account's creation are used to help you sort what type of account it is. For our Run As Action account, to access an Oracle database, we'll be choosing the Oracle Database Account Profile. This profile is not a privileged profile and requires a minimum set of privileges in order to connect to the Oracle Database instance and retrieve the full set of data. Configuring the database provider. Configuring the provider involves the transfer of login credentials from the Oracle Database instances to the Oracle Database host from the Operations Manager. It's best practice to use a task for this when building a management pack. Doing this as a task will reduce the time needed and errors involved in manually setting up credentials for each database host. Let's use a task to configure the provider for the Oracle database. The database login credentials are defined in the Oracle Database Account Run As profile. From an Operations Manager console, click Monitoring. Expand the Oracle Database Server list item in the monitoring pane. Click on the Instance dashboard. The tasks used to configure the provider are listed in the Oracle Instance Task area of the Actions pane. Click on Credentials Set in the Oracle Instance Task area of the Actions pane. The Run Task Credentials Set dialog is displayed. Complete the dialog as follows. Under Run the task on this target, click the checkbox for each host on which you want to configure the provider. For task credentials, select Use the predefined Run As account. Click on the Run button to execute the task. A task status dialog is displayed that shows the status of the task. Click the Close button to close the dialog. Upon a successful deployment, you will now be able to see your database health and performance alerts metrics.
All right. So now we're going to be talking about some of the database metrics that you would like your management pack to do. From a best practice standpoint, in collecting metrics, there are a few that we would like to bring up. First, you always want metrics that are easy to collect. You never want to pay a heavy price in collecting performance metrics that will affect the performance of the systems you're managing. You also want metrics that are easy for your operators to understand, and not just the developer of the management pack can interpret them. There are literally hundreds, if not thousands, of performance metrics you can possibly get. But in the end, you only want to focus on those few which are meaningful to your specific environment or application. Another very important aspect in deciding the metrics you want to make sure is that it's not overly sensitive. We mean that metrics should actually reflect a change in your environment, on your database. And the monitor should not fire uselessly and give you false alarms. Metrics should not jump around or fluctuate on its own without a real change in the system. Now let's look at how common database servers collect and expose various metrics that are essential for meaningful database server performance monitoring. As it turns out, all of the commonly used databases have already built-in facilities to collect useful metrics, counters, and etc., and store them in internal tables. These tables have different names. In Oracle, they're called vtables. In DB2, they're called snapshots. There is a sysmaster table in Informix, MDA tables in Sybase, and so on. But they all share common properties. They represent data collection and counters provided by the database server itself. There are various ways of accessing this information from outside as well. And most common ways are native client SDK calls and SQL queries. So let's look at specific metrics. To start, let's start with something that basic but is very important, the baseline. In any database environment, you normally want to know the total number of commits. Every time a database transaction is finished, a commit is performed. So knowing the number of commits tells you the number of transactions your database has performed. That means the number of successful transactions. And then you can use this number as a basis to normalize any performance-related metric on a per transaction basis by a simple operation of division. The sum of number of commits and number of rollbacks is equal to the total number of all transactions, successful and failed. Number of commits and number of rollbacks are important metrics because any significant changes in them may indicate a condition that requires your attention. Rollbacks are quite expensive operations, and high counts of rollbacks can indicate that a branch of SQL code is failing, and the whole transaction is forced to be rolled back. Excessive commits can lead to performance problems. Queries shown on this slide illustrate how we can retrieve these metrics on Oracle database. Buffer cache hit ratio is a metric showing the efficiency of transactions. It shows the rate at which database engine finds the data blocks it needs in memory over the lifetime of an instance. So ratio of buffer cache hits to total requests. Essentially, it's the probability that a data block will be in memory on a subsequent block reread. Correctly tuned buffer cache can significantly improve the overall database performance. So this example query shows how to calculate this in case of Oracle database. Another metric has to do with efficiency of indexes. So efficiency of indexes is important because your index may be not accurate and needs to be rebuilt. When you start to frequently run into a situation where a given key is not found in the index. Memory sorts versus disk sorts. So disk sorts are extremely inefficient operations. They are hundreds of times slower than RAM sorts. If the number of disk sorts is far greater than the number of memory sorts, and your user is complaining about response time, it's probably something you want to look into. So maybe your application simply needs to change the way it works to make sure everything fits in memory, and so your sorts can be much more efficient. Another metric is log wait times. Excessive log wait times are typical cause of the poor database performance. This metric indicates the average wait time on a log. Usually, it's high if the table locking is used as opposed to row-level locking. Deadlocks. Deadlocks are quite rare in production, but represent a fairly serious problem because they lead to unresponsive database queries. Absolutely need to be monitored, and alert absolutely need to be generated in case of any detection of any deadlocks in your database. Large table scans. And it's one of the metrics that you should know about, you should know whether large or full table scans are happening and whether it's happening often enough. This has to be relevant to your database and application environment as well. If you have a data warehouse application that needs to read everything in from time to time, this may still be okay. However, if you have online transaction processor application environment and a high number of full table scans, it often means a tuning opportunity. If a row only gets retrieved after running a large table scan, a full table scan, it means that you probably should build an index. And so the result row can be fetched much faster. It could also mean that your index that is already there may be not that effective due to some updates or deletion of the keys that you were not expecting, and you may have to regenerate the index. High cursor counts. Open cursor takes space in the shared pool. There is nothing a DBA can do to fix a cursor leak. The application developers need to go through their code, find the cursors that are being used and left open and close them. Some databases, such as Oracle, allow you to specify the upper limit of the open cursors. In this case, the best advice for tuning open cursors option is leave it unchanged. Set it high enough so you don't have to worry about it. If your sessions are running close to the limit, then you can raise that limit. Table size usage is the metric that every database offers, and table size is probably the most widely tracked metric in any database environment. You can do something really simple or something fairly complex to get to the fine details of each table you want to track. Of course, you need to worry about the limits of the actual physical free space on the underlying storage device as well, especially when the table is set to auto-extend. Of course, your database is going to perform just as good as the host that is running on. You need to pay special attention to the host where your critical databases are running. This is especially true in a virtualized environment. We have seen this kind of scenario quite a bit from our customers in VMware environments. As an example shown here, the DBA configures a VM with 16 gigs of RAM for the database and knows that 16 gigs is optimal amount for this database to perform. But for whatever reason, maybe because people work in different IT silos, that machine gets deployed, that VM gets deployed with a memory limit set by the policy or some kind of generic template used by the infrastructure team. So you're trying to monitor from within the OS host metrics like memory, it will happily report back that it is seeing 16 gigs of RAM and probably just using over 80% of this 16 gig. But the OS does not know that it actually has 8 gigs of RAM only because of the memory limit set at the hypervisor level. And it's actually suffering badly already and affecting database performance level to level beyond critical. You have no way of knowing this unless you're monitoring at the hypervisor level of that specific VM. Of course, you can easily do this if you happen to have a management pack for your virtualized environment as well, and build the relationship between the VM and the database using the distributed application designer and operations manager. And by the way, BridgeBase offers VMware Virtualization Management Pack. So now I'm going to do a brief demo of how BridgeBase Management Packs for various databases show and use these common core metrics that I was talking about. So I'm going to switch to my demo environment. All right, thank you, Randy. All right, so we'll start with the BridgeBase Management Pack for Oracle database. Performance metrics are collected per instance, per Oracle instance, and are shown in a number of performance views here under All Views. So we can explore what's there under All Views and find a lot of stuff there, including all the commonly used metrics that I was mentioning. So you can see here number of commits and number of commits per second. You see a number of rollbacks and rollbacks per second. Rollbacks per second. I don't have any rollbacks. Number of transactions per second, which is a derived metric. Very, very useful metric for your baselining. Buffer cache hit ratio is reported as buffer cache hit percentage. Index efficiency is represented by two views. One is called index fetch full scan, and another is called index fetched by key. You can also see memory sort rate. That represents your rate of disk sorts versus memory sorts. You see session lock weights. That represents your how long the session is waiting on locks. You see deadlock counts. I talked about deadlocks earlier. Deadlock count here. Obviously, I don't have any deadlocks, otherwise I would be in trouble. Table scan long tables and table scan short tables represents the number of full table scans required. Table scans, short tables, and long tables here. All right. Open cursors. and table space % usage used. So all of the essential metrics that are absolutely crucial to be monitored in databases are available from this management pack right out of the box. Now, these metrics are collected and shown in performance views, but those same metrics are collected using rules and can be further used in monitors in order to generate alerts when a certain threshold is exceeded. So when we go to authoring and we explore management pack objects, you can see rules. Takes a bit of time. So takes time to filter. Management pack for Oracle database offers 66 different rules we have out of the box to deal with common Oracle database metrics, and we offer over 40 monitors that are preset out of the box with certain thresholds. Of course, these thresholds represent commonly used thresholds. They by no means indicate that your organization should be using those same values. Determining which values you need to use is part of the process of tuning your management pack implementation to your specific environment. Initially, most management packs, when they're installed from any vendor, they typically tend to be pretty noisy. So the common approach is to carefully relax these thresholds to make these monitors less noisy and make them more relevant to your environment. All right. So now we are moving to management pack for DB2 database, and we'll see those same metrics displayed and presented in a bit different way. In DB2 database case, most performance metrics are present per database instance, not per instance of the database engine, as opposed to Oracle. And some metrics are collected at the buffer pool level. So most of the database performance, you see all these views here. So let's look at the transaction view. It will show you summarized view of your commits and rollbacks and some of these. Going to cache hit ratio, you will see very similar things you just saw in Oracle. It's just presented here in a variety of different metrics. Index efficiency, we're looking at under buffer pools. It's called hit ratio. You see index hit ratio monitored here in this view. Sort efficiency is available from the sorts summary view, which contains sorts and sort time in milliseconds. Locks and lock wait time found under logs. Table space is monitored through its own table space containers. And you can see in performance area, you see table space containers of utilization. And you see table spaces utilization here as well. So databases are very different, yet they offer very, very similar core metrics available. So now we are going to switch from this demo back to the main screen. And I'm going to talk a little bit about clusters. So we see quite a bit of interest from our customers on running their databases in clustered environment. Quite a few people run their database environment, for example, in the Windows Server cluster, just for the sake of high availability and failover if the primary node goes down. This is commonly called an active-passive cluster, since the non-primary mode is passive when the primary node is operational. In addition to high availability, clustering technology is often used to increase computing power by means of grid computing. Oracle called their database engine Oracle 11G, where G actually stands for grid computing. So let's look at scaling up versus scaling out. When you have an application that runs out of resources of your current computing power, you can try to scale up vertically. By this, I mean that you could try to add more CPUs or memory, but still using one box. You can only scale up to a certain degree by adding more CPUs and RAM. And besides, multi-socket machines beyond 2 sockets are quite expensive, and it makes very little economical sense. So another approach would be to scale out horizontally by adding more economical machines on a larger scale. Oracle RAC, which stands for Real Application Cluster, is actually an active-active cluster. In that sense, it is actually not only providing high availability, but all the nodes in the cluster are active, working nodes, and they provide more computing power. The database is located on shared storage, so all the nodes can access it concurrently. All the nodes are connected by a dedicated high-speed private interconnect, for example, a gigabit or 10 gigabit Ethernet, InfiniBand. So all the nodes can communicate together to keep things in sync with cache fusion technology from Oracle. The dedicated high-speed interconnect is critical in any Oracle RAC implementation and is a main channel for Oracle RAC to synchronize all cache, all locks, and other global resources across all the nodes. So let's look at Oracle metrics, Oracle RAC metrics that are useful for monitoring. The most important metric is in Oracle RAC is probably the global cache latency. Typically, you track both the consistent read and the current read latency. As you saw in the diagram, in the previous diagram, all the nodes ship blocks of data through the high-speed private interconnect to keep things in sync. So any information any application can get back would always be either the consistent block or the current block, depending on the query. If an application asks a node for a row that is contained in a data block in another node's buffer cache, then that data block needs to be shipped over to the node serving that request. So we really want to make sure your average cache latency is low. Ideally, it should be below the threshold of 1 or 2 milliseconds. If it is high, you should check your interconnect response by a simple ping to make sure that it's not a network issue. If it is not a network issue, it often means that remote instance is very busy, so you will need to look into rebalancing your workload across the nodes. Global NQ service is in a single instance Oracle. NQ is basically a lock that allows for parallel access to Oracle resources by using a queuing mechanism. In RAC environment, this locking mechanism needs to be extended to the multi-instance level across instances on all the nodes. Anything that's not cache related is managed by what is called a global NQ service. The busier that service gets, the longer the lock waits. Ideally, you should only want to be, you don't want the lock weights to be more than a couple of milliseconds. Balanced workload among nodes. Of course, you always want to track whether all of your nodes' workload is balanced or not. An occasional spike here and there is probably okay, but if you see a consistent unbalancing of workload, it means that you really have to look into how to balance your workload better in a more intelligent way. So maybe your round-robin strategy is not the best approach. You need to decide whether a certain workload should always be assigned by a specific set of specific nodes to maintain a better balance. So I'm going to do a brief demo of the Oracle RAC management pack that Bridgebase just built. Okay. So you see a number of views that are performance views for various metrics relevant to Oracle RAC. I was talking earlier about global cache latency, and it's available in here. There is a global cache right there, and performance details. You get all these metrics for and this is the most critical thing you need to watch about the performance of your cache. And the management pack is able to generate alerts in many cases when monitors fire and detect problems with either log times or send times being too high. So in this actual setup, I actually have some alerts generated here that tell me that my block receive time has exceeded the critical threshold. So this gives you an idea on what is essential in monitoring the Oracle RAC setup. The workload can be judged by looking at how much CPU each node uses and how much memory each node is using. So looking at these two views, you can figure out whether your workload on the Oracle RAC nodes is even. Of course, in addition to these views, there is a number of monitors you can build yourself based on the existing metrics available. So that's basically a brief demo of Oracle RAC. And now I'm going to pass this microphone to my colleague Randy. And Randy is going to talk about some other exciting stuff.
Okay, thank you very much, Oleg. Now, I just want to take a minute and explain a little bit of something that we announced this week. I don't know how many, I don't have any Bridgeways customers, but I'm sure many of you have heard of Bridgeways. I'm personally with Silect. I'm product manager. We've been in the space for approximately 10 years, and on Monday we announced the merger of Bridgeways and Silect Software. So that's why Oleg and I are here together today. So it's going to be exciting for our customers, some of which are out here today, bringing the strengths of both companies together and packaging up, bundles of products to help. Now, Oleg's been talking about management packs. I'm going to talk a little bit about best practices here today. I don't know if I have a pointing device here that'll allow me to speak to this screen a little bit better. Is that it? Okay. So what I'll do is I'll just walk you through this slide a little bit. And I'll draw your attention to the upper left-hand corner. There's a block here that says Analyze and Document. So this is one of the first things you may be asked from stakeholders on the team is, what's in my management pack? what's running on my server? How are the overrides configured? So this is one of the big questions I get all the time is, how can I share that information? How can I document? In MP Studio, we have the ability to export with a single click the entire configuration of your management pack in a minute. So in terms of best practices, many of our customers are required to audit their management packs. And to do that, they document the configuration. So this is a best practice. In terms of analyzing that management pack, really the custom settings are all in the overrides. And so I'm going to talk a little bit more about override management here in a minute. So let's move to the left in that workflow. This really is the life cycle of a management pack. So you've got that management pack you're going to deploy into your environment, but how many guys have actually been forced to put a management pack in production directly? And how did that work out? Did you end up with unexpected alerts? So it can be very painful, and I know I've heard lots of horror stories from our customers. In the range of thousands of alerts can be generated very quickly just by simply deploying a management pack in production. It's hard to have a lab that's going to simulate your production environment, simulate user load. So, however, it is a very important best practice to go out there and test the management pack before you put in production. So if you've got an ops manager lab, that's great. That'll help. Now, what you're actually doing is you're validating the performance. Are you getting alerts for the conditions that you expect? Secondly, are you getting alerts for conditions you don't expect? In other words, false alerts. So we're looking for these scenarios, and you need a way to measure that. So you can look in the Ops Manager console and see alerts in there. You can set up the notifications. You can wait for support teams to call you and tell you that you're being flooded with stuff. However, I'm going to give you a little bit of a demo here later how you can test a management pack without actually putting it in production. With MP Studio, you can simulate that management pack being in production, collect real-time data from your production server, RPC-based collection, just like running Event Viewer or Perfmon. Grab that data, bring it back to your MP Studio install, and compare it to the configuration of the management pack. So now I'm not flying blind putting a management pack into production. So with that particular test feature, we're going to generate a scorecard, if you will. We refer to it as the resultant set of alerts. And as a customer told me when testing the Exchange Management Pack, 20% of your rules and monitors will generate 80% of your alerts. So if you can find those in a test before you roll that management pack into production, create those overrides, tune those overrides, and really this sequence, validate the management pack, assess it, and then tune it. That repeats itself until you're ready to move that management pack into production. Okay? So that's a very popular feature in the product. Best practice, measure that impact before you put it out there if you can. Okay, so just moving down a little bit in this diagram, right there, sort of central, is the version control database. Now, natively speaking, you've got management packs in your Ops Manager environment, but you don't really have a way to manage versions. And you could have an override management pack and you've made some changes, or somebody has made some changes inadvertently. All of a sudden you're getting flooded with alerts. You're not really sure what's causing them. All you really know is the pack that you had last week was working a lot better. So with MP Studio, and as a best practice is to have a version control mechanism. Save those management packs. As you make changes, put a copy into the database. And what I'll be able to demonstrate here for you momentarily is the ability to audit those changes as you put the management pack into the database. So hopefully we'll get a chance to peek at that as well. Okay, so at the back end of that, as you check in management packs, we're comparing those two management packs, the old copy and the new one you're putting in. You also have the ability to compare any two management packs in an ad hoc basis. Now, why would you want to do that? If you're considering deploying a new management pack, how do you know what's different between your production version of that SQL 2008 monitoring MP and the newest one you got from Microsoft? Again, you could be flying blind if you throw that into production, just upgrade, right? So you might have a lab, but it can be difficult. You might multi-home agents, and so you've got a pretty good lab that way. But it's a best practice to do some impact analysis. Try to understand what's changed in that management pack. What have they added? What have they deleted? And what have they changed? So that's just, as an example, Microsoft from somebody like Microsoft, or even Bridgeways. If you've got, their older version of the VMware ESX MP, and then you upgrade to the newer one, it would really make sense to take a look and see what they've changed. So with MP Studio, you can do that kind of impact analysis. And why would you want to do that again? New rules, new monitors that might create alerts. And maybe you want to create some overrides for those things first. Okay, so just in summary, this diagram really represents the features in MP Studio. That's the text outside the block. The text inside the blocks represent the best practices, okay, in the life cycle. Now, I've got a white paper on the life cycle for management packs available. If you wanted to come by our booth, or right beside the Bridgeways booth, I'd be happy to get your email address and I'll fire that white paper off to you. Okay, Oleg, what time do we finish up here? Okay, so we've got 10 minutes, which is perfect. I'm just going to share with you my environment here. And the first block in that workflow represented documentation. So what I'd like to do is show you just a couple of ways to do that. What we're looking at right now on the console here, on the left-hand side, I've got three sources of my management packs. I've got the store database, okay? This is my archive, and if I just expand this one folder, you can see, for example, I've got multiple copies of my Active Directory override MP in there. I've also got all the sealed Microsoft MPs, Bridgeways MPs, you name it. I can put them in the database. Now, just below, I've got a registered management group in here, and these are my production MPs, okay? We've opened one of those MPs, the SQL Server 2008 monitoring MP. Now, in terms of documentation, there are lots of things you can document. One thing I like to show is the reference tree. This just gives you a graphical representation of that management pack, all the management packs that it depends on. I can see version numbers. I can get a little bit of information on the number of rules and monitors in each of these MPs. Now, with a simple right-click, I can copy this to my clipboard and include that in a report. But really, I want to put together something that's simple for the guy who owns the box to understand, who doesn't necessarily have an Ops Manager console, or my management is asking me for a report on the configuration of that MP, or maybe I've got to share something with a change management committee. I'm certainly not going to ask them to look at the Ops Manager console. It's a bit of a black box in terms of all that stuff. With MP Studio, let's take a look at documenting this management pack. I'm going to document this to an Excel workbook. Just going to save that on the desktop here. We'll overwrite the existing copy of my SQL Server 2008 monitoring MP. So how many guys, girls, have tried to document a management pack? Anybody? Okay, how long did it take you there to do that? Okay, so the answer there was first time, several days. And I do have one customer who gave me a metric. This was before he ended up purchasing MP Studio. Okay, and I think, let's just do this. I've already got that open, so I'll bring that up. So anyways, this metric was they had to document their management packs for audit purposes every year. It took him 28 days for an average environment. Actually, it was a relative small environment. So if it took a couple of days to document a single management pack, I'm sure you're using a combination of screenshots and some other information that really, you probably had some doubts about sharing it with people who are not necessarily ops manager administrators. So what we're looking at here, I'm just going to go back to the first tab. You can see across the bottom, I've got a separate worksheet here for each of the elements in the management pack. All the configuration stuff is in here. There's some stuff that's a bit meaningless, personally, that they're not necessarily going to want, but you can actually delete those easily in the spreadsheet. So let's just take a couple. Let's look at a couple of these. Here's my rules. I've got 284 rules in this management pack. I'll scroll to the right so you can see a little bit more of that. Here's your data source collection information, right action collection, it's all in here. Let's take a look. We've got the tasks, module types. I'm just going to go right to the end because what I want to share with you is the referencing overrides. So in this particular scenario, I've created 30 overrides and stored those in an override MP. So I've got a nice, neat little package here. If I scroll right to the end, the last column name is overridden MP element. Sorry, that's not the last column. Referencing MP name. So if I generate this report, this is just one way for me to find out if I've got overrides stored in multiple management packs. So if you don't need to audit a management pack, but you do want to find out if you've got overrides stored conveniently in a single, generally speaking, most people are putting their overrides all in a dedicated management pack, right? So this is one way to capture that kind of information in a nice, neat spreadsheet. Okay, so enough on that piece right now. Coming back to the MP Studio console. Okay, and there are several other ways to document. I'm not going to go through each one of these. I'll just give you an idea. At the top here, we've got an Export to Excel toolbar button. Anytime you see a grid or a table like we're looking at currently, you can use that Export to Excel in order to document that individual element. So for example, if I come down here and I pick referencing overrides, here are all the overrides that have been created for this management pack. And I've just grouped it by a couple of things to make that information a little bit easier to understand. So I can group by, for example, context. And you can slice and dice this several different ways, but I typically want to add in this parameter or property. Just makes it a little bit easier to find what I want. Now if I export that to Excel, I'm going to maintain that custom grouping. So we're doing a couple of things here now. We're analyzing and documenting that management pack. So I know we're short on time. I'd like to take a minute and show you the test feature. This is pretty cool. And what I'm going to do is I'm just going to go down to Windows Server 2008 Monitoring. I'm going to right-click on that. You can see some of the things I can do here. I can initiate a comparison. So if I want to do that impact analysis, I want to understand what's different between the copy I have in production and the copy that I've hired somebody to develop an override management pack for. I want to see what they've added to that. I can do that very easily using this ad hoc comparison. I can generate overrides for that management pack. I can document it, view the reference tree. We've taken a look. Let's initiate a test. So the test launches a wizard. And I'm going to go through a little bit of this, and then we'll cancel out, and I'll show you an existing test sample. So I need to have local admin privileges on the boxes I'm testing against. I can add one or more servers to test against. I'm just going to run against my local VM here. Select Next. And on this dialog box, I can configure the duration of my test. By default, it goes to 5 minutes. You could run a test that'll last an hour, a day, a week. We will test every rule and monitor at least once when the test begins. So the next option here is to be able to delay that test. So you might be looking to run this test during a peak load condition, so you can pre-configure the test and have it kick off later. All right, the last two pieces to configure here include the sample rate for event logs and the sample rate for perfmon counters. MP Studio is going to collect that data on this sample rate. So the longer you're running that test for, naturally you might want to fine-tune that so you're not loading too much information into the database. So I'm going to kick this off here, and we'll let that run for a little bit. It's recreating the health model. I'll get any information that it can't collect. It's checking to confirm it has access to the perf counters, to the event logs, to the registry. We're going to run the discovery and actually collect that information, make it available so that you can generate a spreadsheet, reporting and all that. Okay, so that test is just about, there's a little bit of setup information. It's preparing to run that test. Usually I get questions like, well, do I need to have the management pack deployed out there? The beauty of this product is we're simulating the management pack being deployed. And how we do that is we've got the copies of the management packs locally on MP Studio in the store database, right? So we can cache all the information about the referenced MPs, about all the overrides. That information is all loaded into memory. Then we make that RPC connection and start collecting the data and comparing it against the configuration of the management pack and serve up the alerts in a view inside our console. So you're not actually creating any alerts in your Ops Manager environment. You're just seeing what would be alerting if the management pack got deployed as is in that environment. Okay, so I'm going to click Finish here, and I'm going to then talk a little bit about this test view. So here we're looking at a few tests that I've run. The current one is not showing any alerts just yet, and there's the first alert just came in. So we can see that in the resultant set of alerts table on the other side. Now, just to bring it back to best practices, if I'm going to create overrides, my boss has asked me to do a health check or create some overrides and tune this management pack up, I'm going to test it first on day one before I do my work. I'll test that management pack. The resultant set of alerts report is going to give me a metric, how many alerts per hour it's generating. Now I'm going to go in, start tuning the overrides, creating some, maybe disabling some rules that really I don't need that information anyways. Then I'm going to run a second test and compare the number of alerts generated in test A to the number of alerts in test B. Then I can go back to my manager and say, I've reduced the alert volume from 10 alerts per hour to 1, or from 100 alerts per day to 2, that type of thing. So in terms of best practice, what I'm doing is creating a baseline to know the alert potential for this management pack. So we've got lots of alerts. Just before we look at one of those, I want to right-click here, show you a little bit of data that's being collected in the background here. Just briefly, here's the discovery report. I've got the target information and then the data collected per target. I can export that to Excel. But what I want to show you here is the performance counters that we're collecting as a result of what's in the management pack. And I just double-clicked on one of those. This is real-time data we're looking at. As the alerts come in, they'll show up as dotted vertical lines. If I just put my mouse over that, you can see the alerts that occurred here. We can see right at the peak of the total percent DPC time, there was an alert that came in here. The solid vertical lines, these are events that occurred in time. Okay, so this is interesting information to help me actually troubleshoot the application, the OS, and in fact, the management pack. Because I can now go in, let's take a look at these alerts, and I'm going to wrap up here momentarily. From the alert, I can select the different alerts, and remember, 20% of your alerts will generate, 20% of your rules and monitors will generate 80% of your alerts. And so I can see very quickly here which ones are generating all those alerts, disk read latency. If I can tune that one, I can really save myself a lot of headaches. So when I select an individual alert, down below, we've got the knowledge base article. You can read that, and then I've actually got a link right here called Overrides. If I select that, this is going to open the management pack I'm testing. It's going to find the rule or monitor responsible for this alert, and it's going to show me the overrides. And I can tune it right from here. So I've mentioned this particular management pack I'm testing is installed in my management group, but with MP Studio, we support working with file-based management packs. That means I can test a file-based management pack sitting in a file folder on my hard drive with zero impact in my production environment. I can create overrides for it offline and test that management pack again offline. Okay, so here you can see in the background, we've opened the management pack, and I purposely set some of these alerts, some of these overrides to 0 in order to force alerts. I'm just going to show you another feature here. We'll apply that change, commit it. That's saving that into the management pack, and now I can actually go back once this completes, and I'm going to put a copy of that in the database, if you can bear with me for one more minute, and then we'll open it up to questions, okay? So that's just about done. The reason I want to put that into the database is I'm going to seamlessly audit the changes. So I don't know how many of you guys have done like I've done. I've made changes one week, and I come in on Monday, and I found I've actually caused some problems. Couldn't remember the changes I made the week before. I was in a rush or whatever. I was able to go back and look at the audit history, see exactly what changes had been made, and then I realized, okay, that's the one. Go back in, edit that override, and get back to square one. Okay, so that's just about done. We're just going to finish this whole sequence by coming back to the management packs view. And that was the Windows OS MP we were working with. Here's my, there it is, that's Active Directory. The bottom one is my override for Windows. I'll right click on that, check this in. Okay, and here's my summary. Now this is basically using the comparison engine in the back end here. We can see the revision. It's incremented it up to 11. The previous one in the database on the left-hand side was my version 10. So you've got your version control here, a summary of the edits in that middle row, and then down below, we've got the details, and we can see, for example, on the bottom two items, here's where the previous value was 0. I've changed it to 50 and 60, respectively. I can come in here and add some notes if I want more details, who requested a change, maybe why that change was made, commit that into the store database, and actually, now that I've got it in there, I might choose to roll back to a previous one, and you can deploy that right from the GUI. So I promised I'd show the audit history. Here's the audit history. I can group that by user, so if you've got multiple people making changes, this will allow you to group by user and quickly find out who made what changes and when. You can see there's a changed on column here. That gives me that date timestamp. Now, I know at least one of my customers in here, and he came by and we talked about this, but you've got two choices. If you want or need to audit management packs, you're either doing it manually and keeping a spreadsheet, or you can do your edits in MP Studio in order to do that and be able to audit it. So I guess we should wrap up, right, Oleg? Okay, so there's lots more I could show you, and I know Oleg's set up at the booth. We'd be happy to do further demonstrations. I didn't get to show you the override management. MP Studio, 16 times faster creating overrides than you can do it natively. And I'd be happy to sit down and do a bake-off if anybody wanted to challenge me on that. But I could show it to you. It's very quick. So, are there any questions either for myself or Oleg? Okay. Yes, that's a good question. What you can do is you can right-click on a management group, and what I want to do is, okay, that's on the wrong folder down here in the management group level. I have an option here to explore workflow, and I'll specify an individual agent. Oops. Let's try that one more time. Explore workflow on an agent. Okay, we'll kick that off, and that'll come up. But to answer your question, yes, we'll report the rules, monitors, and discoveries running on any given agent. You can link from this report. This will report all the rules, monitors, and discoveries on that agent. Then you pick the rule or monitor of interest, and it'll jump to the override configuration. So I know you're looking for the silver bullet. If I had $1 for every time I was asked for that report, it would be pretty big. This is going to run and complete here. Once it finishes, I'll share that with you. Any other questions out there? Does anybody have one of these buttons on them? You're not with Bridgeways, are you? How's your catching hand? Anybody else? Got a button like this? So if you come by our booth, pick up a button. I've got a couple here if you want one. And if you get spotted by one of our spotters, these are $5 casino chips. If you've got a button here, come and show me, and I'll give you one of these here. Otherwise, I've got some buttons. You can take one with you. Any more questions for Oleg or myself?
So in the traditional council, do you also support any auditing of changes that happen outside the
We do. Excellent question. We'll catch what was changed. Okay, so you change the threshold. We'll catch the last change based on the time you checked it into the store database. So you can make those changes. Here's the report you asked about. I've grouped it by type. And you can just see the title at the top of the tab is, we've discovered 1,200 and some odd rules, monitors, and discoveries. I've customized the grouping by type. I can also come in here and add this MP name. And now I can tell you I've got 16 different management packs running at least one monitor on this agent. In fact, 147 of them are the SQL Server 2008 monitoring. Now, I mentioned this jump to capability. If I want to view this particular monitor in the actual MP and see the overrides, I would just select this option. And it'll open that SQL MP, find that monitor.
It's hard to give like an effective mistake or like a DBA. You know, these file groups have these percents or these drive have 20%.
Yeah, that's a little bit more detailed than we're capable of doing today. So.
Yeah, I just wanted to ask if anybody has any additional questions about the products we were showing. Please allow your badge to be scanned, and then we will get to you and provide you with extra information. So you can get your badge can be scanned on the exit of this room. All right. So.